Alright, in this video we are going to talk about creating scatter plots, and even more specifically we're going to talk about drawing a line of fit to match our situation. So if you take a look at this is what we worked on the other day with getting these scatter plots all set, and I want to draw your attention to a couple of things. First of all, graphing the data on the scatter plot, make sure you label the axes. So this is a year since 1995, since that's our X value, and the trees planted would be our Y value. I want to talk about the units that I use to go up by here. If you look at your X values here, they go from 1 to 9. So we usually like to start at 0 if we're going to do all positive numbers. That's why we've got the L graph, because they're all positive numbers. And if you go from 0 to about 9, if you went up by 1s, you'd get to like right about there. So going up by 1 should be fine. I labeled every other one because that way it gets the numbers don't start to kind of run together. And then if you look over on the left hand side at the y-axis, again all positive, and they go from about 0 again to about 360. The way I got I went up by here is I took the range of that, which is 360, and I divided it by 14 because there's 14 blocks. Alright, and when I divided that, I got about 25.7, I think, somewhere around there. And so 25 would be just not quite enough. The 360 wouldn't quite get on there. I don't like to go 26, 27 because I like to have nice whole units so that I can see kind of the values a little bit better. So I went up to 30s, and I said 30, 60, 90, 120, 150, 180. So basically I went by 30s, but I only labeled every other one so that I've got a little bit more room to put my values and they don't blend together and so forth. All right, so that's making the scatter plot. The next thing we did was find the mean or average of the X values and the mean or average of the Y values. All right, and that's the point that you really kind of want to make sure that your line of fit goes through. So what I'm going to do now is I'm going to take a ruler, and it helps if you have a clear ruler so you can kind of see a little bit of the points. Sometimes you can take your ruler and kind of set it up like this so that you can look at it and say, alright, well I've got 2 points below right now and I've got 2 above. You don't have to have an equal number of points on the top or on the bottom, but you want it to go somewhat through the middle of your data. So it's going to look something like this. And if I just slide that down just a little bit, my graph is going to look something like this. So then I just draw my line through. And if you notice, if you look at it, you know, we've got this one's a little bit above, a little bit below, a little bit below, pretty close, and a little bit above the line. So it's not going to be perfect, and not everybody's going to have the same exact line, because this is a line of fit. If we're trying to find the line of best fit, we'd have to use our calculators to do that, and it would be doing calculations that we don't even, we haven't quite got to and won't get to in Algebra 1. So if we're looking at this though, now we've got our line. Alright, so we drew a line in, and make sure your line goes through the coordinate from question D, and it does go through that coordinate or really close to it. If it's just off, it's not the end of the world, but you want it to be pretty close to it. The next thing you want to do is write the linear function to model the line you drew. Alright, so in order to write this function, I need to use 2 coordinates. I can see right here that it goes through 2, 0, and I'm going to make just a small little table up here at the top so that you can kind of see the values that I'm dealing with. So x and f of x, and it's going to be 2, 0. And then let's see, it also looks like it goes through this coordinate right here, which is 4, 90. So I can use these 2 coordinates, and I could find more if I wanted to along here, but I can use these 2 coordinates to get an average slope. Alright, and if we look here, my run is going to be 2, while my rise is 90. So my slope is rise over run. So 90 over 2, which is